In the latter half of this course, we've been discussing the nature of reality. Our study of relativity explored the question of whether space and time are mere conventions or whether they are truly substances through which objects travel. Indeed, they may be one substance, space-time, and this led us to wonder about time travel. Our study of quantum mechanics suggested that the fundamental nature of matter may not be as it seems. At the quantum level, nothing is solid with a definitive location and momentum. Perhaps the true nature of reality is best represented with a probabilistic wave function. And perhaps when we engage the quantum world by observing it, we become part of that wave function and exist in two universes at once. This led us to explore the idea of possible worlds and the idea that we may live in a multiverse. But it's possible, indeed how probable this is will surprise you, that everything that we have learned and the modes of reality that science suggests are wrong. And it's not just because scientific theories may merely be useful instruments for making predictions but don't actually describe reality. Space-time may not be a substance, and probabilistic wave functions may not describe quantum particles, because one very fundamental assumption about the way the world is, an assumption that we've been making, may be wrong. Indeed, we may live in a multiverse, but for an entirely different reason than the reasons that we've discussed. Our universe may simply be one of many computer-simulated universes. Yes, the fundamental nature of reality may be digital. We may be living in a computer simulation. Now, this is not an epistemological problem. Epistemologists, those who study knowledge, have long used the idea that we live in something like a computer simulation to expose our intuitions about what knowledge is and challenge the assumption that we know anything at all. Such philosophers harken back to Descartes, who wondered if he could know anything for sure since he couldn't know for sure that he wasn't dreaming. And of course, when you think about it, we've all had that dream that we were 100% convinced was real, even though it was not. Can you be 100% sure that you are not in such a dream right now? It seems not. But if you can't know whether you are dreaming right now, how could you say you had knowledge of anything you believe? If you can't know the world is real, what could you know? The same seems to be true for living in a computer simulation. So, epistemologists argue, the inability to know for sure that you're not being fooled right now by a dream or a computer simulation into thinking the world is real when it's not challenges our ability to have knowledge. But such epistemologists are not arguing that we are in a computer simulation. They are just suggesting that our inability to 100% prove that we're not threatens our ability to have knowledge. Personally, I think the way out of this problem is to suggest that knowledge does not require certainty. Yes, I can't be certain that I'm not living in a computer simulation, but I don't have to be to know that I'm not. But the argument we will be considering today does not merely suggest that our living in a computer simulation is an hypothesis that we can't 100% disprove. No, this argument suggests that it actually may be true that we are living in a computer simulation. Again, it doesn't conclude that we actually are, but it does suggest conditions under which we should conclude that we live in a computer simulation, and then points out that those conditions aren't as unlikely as you imagine. And so, the probability that we live in a computer simulation is not as unlikely as you would imagine. It's actually about 20% likely that we live in a computer simulation. Now, how does this argument go? And why 20%? To answer that, we need to set up the argument by reviewing some of the things that we have talked about in the course. First of all, recall that the existence of our mental life, our mentality, is 100% dependent on and produced by the activity of our neurons. It is because the neurons of our brain are wired and fire in certain ways that we have the sensations that we do. Our visual sensations, our tactile sensations, what we hear, what we smell, what we taste, everything is produced by the activity of the brain. And all of our mental life, our thoughts, our beliefs, our decisions, are reactions to what we experience. But the reasons that we have the sensations that we do is because our organs send electrical signals to our brain. For example, when I see a tree outside my window, it's because light reflected off the tree hits my retina in a certain way. That sends a certain kind of signal to my visual cortex, and then my brain uses that information from that signal and interprets it to produce the experience of a tree. But think into the future where we completely understand how the brain works and how it interprets the signals sent to it. Suppose we understand exactly what signals my eyes send from my retina to my brain when I see a tree. It literally is an electrical signal. So if I was quite devious, and I am, I could kidnap you and hook you up to a computer that hijacks the signals that your eyes send to your brain and send whatever signals I want to send to your brain. If I want you to see a tree, I just send the appropriate signals and you see a tree. And since I am sending and your brain is receiving the exact same signals it would if you were really seeing a tree, and thus your neurons are firing in exactly the same way, the experience you would have would be indistinguishable from the experience of a real tree. You would think that you were seeing a real tree. And suppose I were to do this with all of your senses, hijack them all, and hook my computer directly into your brain. I could control everything you see and hear and feel and taste and smell. I could create an entire world for you to experience. We could call such a device an experience machine. This is actually the plot of the popular sci-fi classic, The Matrix. In the movie, machines have basically done this with nearly all of humanity. They've plugged them into the same giant experience machine called The Matrix. People live out their lives plugged into the machine, all experiencing a world together that seems entirely like a physical world. They don't even know the world they're experiencing is digital. They think they're walking around in the real world when actually their bodies are submerged in goo and they're all hooked up to a computer. The story follows a few people who are trying to help others unplug from the machine. Now, philosophers who argue that we may be in a computer simulation are not arguing that our bodies are sitting in goo somewhere hooked into a computer. That kind of setup would be very inefficient and unfeasible. But I mention it to reinforce the notion that what you experience is a result of how your brain is wired and fires. And how it is wired and fires can be manipulated by outside forces to make you think the world is real when it's not. But to understand the computer simulation hypothesis, we also need to recall what we learned about artificial intelligence. The wiring and activity of your neurons could be replicated on a computer, on a large, advanced, and complex enough silicon hard drive. And since we don't know what is required for consciousness, and specifically we don't know that being made out of carbon instead of silicon is required for consciousness, it seems that we should conclude if the neural functioning of our brain was replicated on a computer, that activity on the computer would give rise to consciousness. It would have a mind. Recall also that we may not need to copy an existing person's neural configuration to produce such an artificial mind. We could use multiple techniques to produce a new unique mind, one unlike any that exists in our universe. We would likely do this by configuring that brain the way that an infant's brain is configured and pre-wiring it to experience the world, but set it up to program itself as it learns. We could then feed the artificial mind electrical inputs, just like the ones you receive from your sense organs, and create a world for that artificial being to experience. Since its silicon neurons would be firing in the same way that our carbon neurons do, it would experience the digital world that we are creating for it, just like we experience the physical world. Even if it were to look at its own brain and study it, if we were to send the exact same kind of signals that we receive when we study our brain, then it would even think that it had a carbon-based biological brain, even though it has a silicon one. Now imagine far into the future where we have massive computing abilities and technology. We can create multiple artificial persons whose brains run entirely on a massive computer hard drive and actually have no physical body. We could then send all of them electrical signals, making them think that they have physical bodies. We could create entire digital worlds filled with digital people that have real minds. They could walk about this digital world and experience it as if it were a real physical world. In fact, they would even think it is a physical world because that is how it would appear to them. That is a computer simulated world. Why would we create a simulated world? There are so many reasons. For example, we could study our own evolutionary history. We could create a world for such beings where they live in pure anarchy and watch how they band together to form civilization. Since we could control that world, we could even increase the time frame and make everything happen in that world more quickly. Thus, we could study the development of that culture in just a few days. We could even see what our future likely holds by watching how they develop ahead of us. Historians would find it of great use. You could figure out what the world would be like if Hitler had won World War II by creating a simulated world just like ours in the 40s, but where Hitler has knowledge of the D-Day invasion. You could settle political disputes. What kind of effect will Obamacare have on the American healthcare system? Create a simulated world in which Obamacare is passed, accelerate it, and watch to see what happens. And finally, simulated worlds would make really kick-ass video games. We already have the Sims games, where you build your own towns and worlds in which digital persons exist, and you watch how they develop and grow. But the programs that run the persons in that world are not nearly as sophisticated as the programs that run in our brains. But what if you could have a Sims game where the people in the world you created had brains that were just as complicated as ours? Persons that were really conscious, that were real people. Ethical considerations aside, and we'll talk more about those in a minute, that would be really fun. So we're imagining a future in which there are computer simulated worlds. One philosopher in particular, named Nick Bostrom, argues that the likelihood that we ourselves live in a computer simulation is directly proportional to the probability that we will one day develop computer simulations ourselves. Why? Okay, it's time to get to the nitty-gritty. Here's why it is way more likely than you thought that we actually live in a computer simulation. First of all, you have to realize that if there ever is a simulated world, there won't just be one. It will be a major advance in technology, and it will likely be used for all the reasons we specified and more. It would be like the iPhone. When you create a piece of technology that is that advanced and useful, you don't just create one. Like the iPhone, pretty soon everyone who can afford one will have one. In fact, if technology advances far enough, we may all have one or more computer simulated worlds running on our futuristic iPhone 6000 or whatever we might call it. So if there's one simulated world, there would be billions. Now, let's grant that there actually is a physical universe. I think that's a fairly safe assumption to make. If so, there are two possibilities. Either the physical universe is one in which computer simulated worlds are never developed anywhere, or they are developed and there are billions of them. So either there's one physical world and that's it, or there's one physical world and there are billions of simulated worlds within it. Sound right? Okay, well, since we haven't yet developed simulated worlds, we don't know which option is actually the case. Whether there is just a physical world or there is a physical world with billions of simulated worlds in it. But if we ever develop a computer simulated world ourselves, we will know that the first option is not true. We'll know it's not the case that there's just the physical world with no simulated worlds, because we created a simulated world. And so, if we ever create a simulated world, we will know that the physical universe that exists would contain billions of simulated worlds. So then the question becomes, how would we know what kind of universe we are in? Are we in the physical world, or are we in one of the billions of computer simulated worlds? Well, as we discussed, computer simulated worlds would look to their inhabitants just like a physical world. There would be no way to tell from the inside that you are in a simulated world. The only thing we would have to go on is the odds. So, what do the odds tell us? Well, imagine that you're in a completely dark room with 1 billion other people and 1 billion hats. Let's say fedoras. Even though the room is completely dark, let's say that you know that there is one red fedora in the room and all the other fedoras are blue. But since it's dark, you have no idea where the red fedora is. Everyone is told to feel around, find a fedora, and put it on. Again, it's still dark. So you feel around and find a fedora and put it on. What should you conclude about the color of the fedora you have on? It's possible that you just happen to find the red fedora, but it's a 1,000,000,000 to 1 shot. Given the information you have, you should conclude that you're wearing a blue fedora. That is most likely. When you can't tell by looking and you just have to go by the odds, that's what you should conclude. Now, if we are ever in a situation where we know that there is only one physical universe, but there are billions of simulated ones in the physical universe, and we can't tell what kind of universe we are in, and so all we have to go off of is the odds. What should we conclude? Well, the odds are that we are in a simulated world. It's 1 billion to 1 chance that we're wearing one red fedora. That is, that we're in the physical world. So, if we ever create a computer simulated world, we will know there is one physical world and billions of simulated ones, and so the likelihood that we are in a simulated world is a near guarantee. So, if we ever create a computer simulated world, it's a near guarantee that we are in one, and so we should conclude that we are. So the probability that we live in a computer simulated world is directly proportional to the probability that we will create a simulated world. So how likely is it that we will one day create a simulated world? Well, there are basically 5 possibilities. First, we may simply blow ourselves up, or destroy our civilization in some other way before we ever get that technologically advanced. So that's one reason it might never happen. Ethical considerations might also prevent us from doing so. After all, we will be creating minded persons who actually feel pain and have rights. It might be wrong to force them, for example, to force them to live in a world in which Hitler won World War II just to satisfy our curiosity. Additionally, we may just lose interest and not think the computer simulated worlds are all that great after all. Furthermore, there may simply be technological limitations that prevent us from creating computer simulated worlds. They may just be technologically impossible. But of course, there's also the possibility that we actually could and will develop computer simulated worlds. So which scenario is most likely? Well, truth be told, we really don't know. And we really have no reliable information to make such a prediction. But when you're working with subjective probabilities, as we are here, a lack of information does not prevent you from laying down probabilities. If you have no information to make one hypothesis more likely than the other, then you just give each hypothesis an equal probability. So what we should do is assign each possibility an equal probability. And since there are 5, that would mean that each scenario is 20% likely. But that means it's 20% likely that we will one day create computer simulated worlds. But if one day we do that, it will be a near guarantee that we live in a computer simulated world. And so we are forced to conclude that, given what we know, the probability that we live in a computer simulated world is 20%. Now that's not enough to conclude that it actually is true that we live in a computer simulated world, but I'm almost certain that probability is much higher than you thought. It's not just a logical possibility that can't be 100% disproven, there's actually a decent chance it's true. To understand how decent this chance is, consider the fact that the chances that you will roll the number you need on a 6-sided die is 1 in 6. The chances that we live in a computer simulated world is 1 in 5, a little more likely. It's more likely that we live in a computer simulation than it is that you would roll a 6 when you need one. Some people have said that they have seen glitches that indicate that we are in a computer simulated world. This seems unlikely. Even if the world is real, our senses aren't very reliable. And after all, the designer of the universe could always just erase our memory of such glitches if he wanted to. But one argument I find fascinating that suggests that we live in a computer simulated world is based in quantum mechanics. The computing power to keep track of everything that would be happening in a universe the size of ours, all the way down to the quantum level, where every particle is and how fast it's moving, would be enormous. But it would also be unnecessary. A computer wouldn't need to know where every molecule in a tree you are looking at would be to give you a sensation of a tree. It would only have to send your brain a tree signal, and only when you're looking at it. Only when we get sophisticated enough to start taking measurements at the quantum level would the computer need to bother with ascribing properties to quantum particles. But could this be why quantum particles don't have certain properties until they are observed by us? Perhaps the computer doesn't bother to give them properties until we observe them. Subatomic particles are a probabilistic wave function because the computer only bothers calculating where they would likely be unless they are observed. This could explain why the particles in the vertical-horizontal-vertical spin experiment from a couple of lectures ago don't take on a horizontal spin in the second measuring device if they are not observed. The computer doesn't waste computing power on rendering them unless it needs to, unless it knows they are being observed. Do mathematical equations best describe the quantum level because it's all just a mathematical equation being run on a computer? Maybe a particle can't have both location and velocity at the same time because the computer can only assign one at a time. Might the quantum entanglement of spinning electrons at great distances be best explained by them both existing in the same computer? The information about their spin is not actually separated by light years, it's all on the same hard drive. In fact, now that I think about it, this might also make better sense of how things like cell phones work. At the most basic level, what is happening is electrons vibrate in your cell phone, and then, as if by magic, electrons also vibrate in sympathy with them in a distant cell phone tower. We hypothesize electromagnetic waves to explain this, but it's not like such waves can be observed. They don't even travel through a medium. Would a pair of electrons' ability to vibrate in sympathy at a distance be better explained by the fact that they both exist on the same hard drive and are thus governed by the same computer program? Now I'm starting to think that we live in a computer simulation should be an alternate interpretation to quantum mechanics. What's more, we have even discovered that our universe is digital in a way. Max Planck, a German physicist who was more or less a contemporary with Einstein, discovered that there are minimum units of distance and time in our universe. It's impossible for two objects to be less than a Planck length apart and to be separated in time by less than a Planck time. In a way, our universe is pixelated, with definite instead of fuzzy distances between objects, just like it would be if it were a computer simulation. I'm really not sure how much water this argument holds, but it sure is fun to think about. So what if we are living in a computer simulation? What does it matter? Interestingly, the point might be that it doesn't matter at all. I mean, if you care about knowing the true nature of the universe, yeah, it matters. So as metaphysicians, we care. Common sense tells us that the chair you're sitting in is a physical thing. The computer simulation hypothesis would suggest that its true nature is digital, a collection of circuits on a hard drive. But science has already taught us that the universe is very different than what our common sense suggests. Atomic theory taught us that medium-sized objects, which seem solid, are actually mostly empty space, the space between their constituent atoms and the electrons, protons, and neutrons that make them up. Quantum mechanics taught us that fundamental particles have no location or momentum until measured. So, the realization that the world is digital may not be that revolutionary. Ultimately, it may not matter for everyday life. After all, even if we are simulated persons, we're still persons. We're still minded. We still experience pain, have emotions, and thus have rights and obligations. It would not be okay to torture someone for no reason simply because they're a digital person. They would still feel pain. If we live in a simulated world, we would still be bound by all the same moral rules. We should still behave exactly as we should behave. In fact, if we have good reason to believe that we live in a computer simulation, perhaps the only way we should modify our behavior is by not talking about the fact that we might live in a computer simulation. Whoever is running the computer simulation may only be interested in it as long as we don't know that we're in one. As soon as we know that we're in one, he may lose interest and shut the whole thing off. So by talking about this, in fact by even listening to this lecture, you may be endangering your own existence. In fact, the existence of the entire universe could be at stake. So maybe you should stop listening right now. I guess it's a good thing that we did this lecture last. But really, it's too late, because now we have arrived at the end of the course. So, let's review. What have we learned? We have learned that the mind is a mystery. It seems to be directly produced by and dependent upon the brain, but how the brain produces it is unknown. At best, we can merely stipulate a fundamental law or brute fact that says that it does. But understanding the true nature of the mind, whether it's identical to the brain or somehow emerges from the brain, if and how it causes anything in the world, and whether it exists at all, is a true enigma. Each view has issues that make it problematic. We might be best off emulating Socrates and merely saying, we don't know. We have learned that the existence of persons is equally problematic. Intuitively, we think it's true that you now is identical to your 8-year-old self, but the proposed criteria in virtue of which that is supposed to be true are all problematic. Even suggesting that persons are 4-dimensional objects stretched across time has its difficulties. It may be that, like the mind, persons don't exist at all. They're just mere conventions. We have discussed many reasons for thinking that humans do not have free will, that human freedom is a mere illusion. The deterministic and indeterministic features of the universe seem to suggest that we are not free, as does the fact that our behavior is dictated by our brain, and our brain is a physical system governed by the laws of physics. And don't forget that modern neuroscience seems to suggest that our brain decides what actions to take unconsciously, and merely creates in our mind the illusion that we consciously made that decision after it is already made. And of course, there is the fact that the basic axioms of logic, which suggest that propositions about the future are true, entail a temporal ontology that is incompatible with free will. Our future actions can't exist before they occur if we are to be free. Of course, if we redefine free will to cohere with the compatibilist notion of freedom, suggesting that we are free as long as we act in accordance with our wants and desires, then we can defend the notion of human freedom. But it seems that is not what most people believe when they believe that humans are free. We explored the possibility that things like universals and possible worlds exist outside our own, and explored the concept of God. We discovered that the traditional notion of the perfect being is fraught with problems. It seems to be paradoxical in many ways. And we saw that one argument that points specifically to a perfect being, the ontological argument, is quite problematic. Other arguments that don't point to a perfect being specifically, but perhaps to a deity of some kind, are also problematic. It doesn't seem that you can establish the existence of God with an argument. But we also saw that the failure of arguments for a conclusion doesn't mean that conclusion is false. So the failure of such arguments just means that belief in God is a matter of faith, and whether faith is acceptable is an epistemological matter, not a metaphysical one. We explored the nature of the universe itself by coming to understand Einstein's special and general relativity. We came to see that, despite Einstein's intentions, it may commit us to a substantival view of space-time. This leads to the possibility of time travel, most likely only into the future, but perhaps into the past, if we can solve the paradoxes that such travel would create. We discussed the nature of the quantum world, and discovered that what makes up matter may be very different than our intuitions would suggest. We discovered the wave-particle duality of light, and that all fundamental particles possess such a duality. We saw that fundamental particles can't have position and momentum, and are not even solid until observed. They exist as probabilistic wave functions that collapse into specific states when observed. We discovered that at the quantum level, there are events that are truly uncaused. It's not that we can't detect the cause, but they literally can't have a cause. And the EPR experiment showed us spooky action at a distance that gave rise to multiple interpretations of quantum mechanics. One such interpretation is that there are multiple universes, and we explored that and other reasons for thinking that multiple universes exist. Even the existence of God gives us reason to think that there are multiple universes. And we finished by exploring another way in which there may be multiple universes. It's possible that there is only one physical universe, but multiple computer-simulated universes. That's the kind of multiverse we may live in. And if we do, it's most likely that we live in one of the simulated universes. And since it's about 20% likely that we will one day create a simulated world, and thus there are billions of them, the likelihood that we live in a simulated world is much higher than you probably initially thought. 20%. Metaphysics, like I said 24 lectures ago, is the study of reality, of things both in and beyond the physical world. It wasn't always easy, and it was probably quite often uncomfortable. A number of your previously assumed or cherished beliefs were likely challenged. And like most philosophy, metaphysics is something that, once studied, is likely to leave you less certain of things than you were when you started. But remember, the goal of metaphysics is not certainty. It's not even knowledge, but wisdom and understanding. And true wisdom can only be had when you admit your ignorance, that you do not know what you do not know.